Hi, my name is Julian Arango and I work together with the Fluid Attacks marketing team in several initiatives. In this webinar, we hope that you can learn some elements that allow you to make better decisions regarding cybersecurity within your organizations. We hope everyone is doing well. This webinar focuses on the question of when a security test is successful. Although this is a topic that sometimes becomes technical, our purpose is that, in simple words, all of you can understand and implement the insights discussed here. In the cybersecurity industry, there are two teams. The red one, those who attack, and the blue one, those who defend. According to that simple definition, Fluid Attacks is exclusively a red team. We attack, then we provide detailed information so someone can fix or close the vulnerabilities in a system, and we check again that these flaws have been fixed. Let's begin with the question of what to attack. Amid an industry that is evolving so rapidly and has become enormous, so big that regulators develop their own initiatives and guidelines, we find different standards with common requirements among them. Industry standards like PCI or HIPAA, or privacy standards like GDPR, or more technical ones like those OSP has developed. We have synthesized the common aspects of different security standards and turned them into security requirements. Here are some of them: session management requirements, cryptography requirements, and finally, credential requirements. You can find a link on this slide for additional information. What does this allow us to do? First, establish a common communication channel with all project stakeholders, such as developers, testers, project managers, business units, and so on. And second, outline the attack. That is, select which security requirements must be tested in the agreed scope of or target of evaluation. After knowing what to attack, the next question is where to attack. Depending on the type of security requirements to check, scenarios and inputs are determined. For example, if the scope is a web application and one of the security requirements to be reviewed is cryptography, we will need to have access to the source code, typically a Git repository. This is important because at the end of the day, what is identified as a vulnerability is precisely the non-compliance with a security requirement at specific points in an application's infrastructure, code, or inputs. The red team's task is also to verify the requirements for all scenarios, such as internet, internal employee, or internal provider, from which an attacker can take advantage of the vulnerability. Expressions such as Whitebox and Blackbox are terms in this industry that refer to the following. When information is provided to the red team, we talk about Whitebox attack. Conversely, a black box attack is the one when only the target is given. It is then a question of deciding the following. Is an attack more effective by providing information or not? However, we solve this duality by asking what is needed to be done: to test the technical skills of the red team or to find the vulnerabilities. On these points lies all the discussion, whether or not to give information. This dilemma is valid. Nonetheless, our approach is the following. Check the ethical and technical capabilities before the test at the hiring phase. The more information the red team has, the faster they will find the vulnerabilities. Consequently, the faster you can close those flaws. If it gives you more peace of mind, there is a gray box approach. The idea is to provide information to the red team as required. This approach helps build trust, but ends up always blocking the test and impairing the red team's productivity. If during an attack, it is necessary to check compliance with cryptography requirements or checking how credentials are being stored on a system, these requirements involve reading source code. However, all concerns and alarms are triggered when the red team requests this input. Several paradigms are surrounding the source code that we want to discuss. First, if I show the code, I lose property rights. Second, if my code is copied, then my business is copied. And third, if I show the code, security is lost. All human beings need to generate trust to develop their lives, and the red team is no exception. Confidence must exist between the organization and its red team. Then show it the code. 1, you don't lose the property rights over your creation. 2nd, if the code is copied from your application or platform, you don't lose your business. It takes more than an application, more than a software for the company to operate, for customers to come and consume your products and services. Besides, all your current and retired programmers already have the code, because that's how a Git repository works. It makes perfect sense to give both the ethical hacker and the programmer equal access to the code. Third and finally, security controls are not in the logic of the code. They are in the password management. Let us address this point from the following question. In the face of a process of continuous change and evolution, do vulnerabilities stop appearing? No, they don't, as technology is always changing and evolving. We're always in the middle of vulnerabilities. The faster they are found, the quicker action can be taken on them. Therefore, having constant feedback, that is, continuous cycles, leads to permanent closures of those vulnerabilities. However, the typical organization's behavior is to run the tests in the final stages of the development lifecycle, or when the regulator demands it. Now, when much time passes between cycles, so many changes occurred or were made so long ago that remediation is practically non-existent. In our statistics, when a single cycle of security testing is performed, organizations close less than 4% of the reported vulnerabilities in 6 months. In other words, organizations end up living with the risk. 85% of vulnerabilities are injected during the software development phase. Our recommendation is to shift to the left and perform the tests from the beginning of the software development lifecycle. To run security tests from the beginning, everything revolves around the code. The code is the common point between developers and testers. The challenge is to have read access to the code repository and access to the integration environment. To run a security test, we must clarify that no matter what methodology the development team uses, that is, the red team must be neutral to cascade development, agile methods, or DevOps methodology. As we said before, everything is about the code repository and the integration environment. We have 3 actors: the developers, the hackers or testers, and the management team. When the developer makes a commit to compile what he has developed, Fluid Attacks realizes this and proceeds to review that code. If we find any vulnerability, we report it immediately on integrates. The developer gets notified about a vulnerability that has been found. He or she then logs in to integrates and reads all the details to understand what it is. Then, in the next cycle, he or she fixes the vulnerability and performs a new commit. After that, Fluid Attacks tries again, establishing whether the vulnerability has been fixed, whether it remains open, or even whether a new one was injected. The management team is made up of stakeholders in the process, such as the project director, development operations and security managers, project sponsors, among others, who can control the entire process and assume risks if a vulnerability is to go into production or to determine the time given to the operations team to fix it. As soon as the code is functional, it is deployed into the integration environment. The source code is executed to attack the application and its associated infrastructure through its input fields and ports. And again, when Fluid Attacks finds a vulnerability, the development or operation teams reviews the report and go ahead to close or fix that vulnerability. When there is access to the source code and the integration environment, it is possible to check the compliance of all security requirements. Now, if the organization has continuous integration processes, that is, uses a technology that robotizes changes instead of having a committee that approves those changes, Fluid Attacks is capable of breaking the build. This prevents insecure code from going into the general repository and even less likely to go into production. Every day we are thinking about how to automate processes and improve their times and efficiencies, and security testing is no exception. However, trying to automate everything and at all points of the process can lead to adverse effects. So we must aim to accelerate smartly. To this end, we would like to share with you some recommendations on how to develop products with speed without compromising security. In other words, hacking at the speed of business. Fluid Attacks encourages all organizations to adopt the following recommendations. First, automatically search for deterministic vulnerabilities. Our analysis found that the best tool in the market could find up to 20% of the system's total flaws. Second, use machine learning techniques to prioritize where to start the process of finding vulnerabilities. Third, use human talent, that is, human intelligence, to discover the rest of the vulnerabilities not detected by automated tools, around 80%. Fourth, break the build automatically. Do not allow identified and open vulnerabilities to be released into production. The purpose is to obtain quick and constant feedback, accelerating in a different manner, for instance, by chasing flaws with automated tools only and without making hard stops by breaking the build, will lead you to not discovering all the vulnerabilities that exist in a system, not getting all the feedback you need and quickly, and spending more money without achieving higher fix effectiveness. As we know well, we need to have metrics that allow us to control and improve processes. To bring you more context, there are two concepts in our industry to keep in mind when it comes to security testing. The first one is associated with reporting lies. That is, vulnerabilities reported as real, but which in the end are not. This is known as false positives. Ask yourselves, do you know your false positives rate? The second one concerns omissions, vulnerabilities not detected during an attack. This is known in the industry as false negatives. Do you know your false negatives or omission rates? It is crucial to find these two metrics, the percentage of false positives and the percentage of false negatives. These two concepts must take full relevance. Not doing so implies serious costs. Think about the moment of remediation. The operations or development team will take time to fix a vulnerability that is a lie, that doesn't exist at all. Or let's go further and think about a more dangerous scenario. If a vulnerability was not reported, the team will fix nothing and will leave a potentially exploitable flaw that could greatly impact the business. If your company already performs security testing, let us ask you something. Do you know the coverage of each security test? What we mean by that is whether all the lines of code and input fields are checked. In other words, if one of those projects you are running security tests for has 100,000 lines of code and say 100 input fields, is the test covering all of them? And we're also speaking if you are performing security tests on all the applications or developments. If you have 10 developments, for example, and run tests on 3 only, then coverage would be 30%. And finally, what percentage of reported vulnerabilities are you capable of fixing? Based on those questions, we can infer two more metrics. One, coverage percentage, and second, remediation rate. This one is the most important metric on the side of the organization. From our taste, it is the most revealing metric of the whole testing process because we see remediation rates of 4% at the beginning when organizations perform just one cycle or one-shot hacking. But when organizations start testing security within the software development lifecycle, that is, testing continuously and breaking the build, the remediation rate rises to 53%, which is the average for organizations. Furthermore, the metric goes up to 91% in an organization's maturity stage. This metric should be your security testing report. This means that when you're asked if you do security testing, you could simply answer, yes, I do. My remediation rate is X%. The other stuff are just details of the past. A security test or testing process is successful when all vulnerabilities are found, there are 0 false negatives, or as we learned, 0 omissions. There are 0 false positives, or as we also learned, 0 lies. And there are high rates of remediation, hopefully 100%. In Fluid attacks, we focus on attacking continuously. And by doing so, we nudge our customers into achieving higher remediation rates, which makes them happy. We invite you to subscribe to our blog at fluidattacks.com/web/subscription. There you will find top-tier articles regarding security testing. Thank you very much for joining us in this webinar. We hope you have enjoyed it. Please scan the QR code to your left and leave us feedback about this content. We look forward to hearing from you.